Hello everyone, so here we are on our journey for the next exam paper, and it is the 2024 SQA examination. First question: convert the following denary number to an 8-bit 2's complement number. So we look at the denary number, it's a negative number, so we know we're going to be reversing our binary digits. First of all, we've got to take the 25 and convert that to a binary number. So we will do that, getting our remainders after dividing by 2, and then we read up from the bottom 8 bits 1 2 3 4 5 6 7 8, and it becomes that number there, 0 0 0 1 1 0 0 1. Reversing the digits method is you reverse all the digits until we get to the last one, and we keep that last one as a 1, but all other digits in front of it to the left of the 1 there are going to be reversed. So it's 1 1 1 0 0 1 1 1. That is the answer, and that is negative 25 as a 2's complement. Right, the largest positive integer that can be represented by 8-bit 2's complement. So we basically know that we have a I'm just getting my drawer. We know that the number of digits, the largest and lowest number is always represented by this 2, the positive number 2 to the power of n minus 1 minus 2 positive 2 to the power of n minus 1 minus 1. So that is our number of positive integers, and that's our highest positive integer, and that represents our lowest negative integer. So the largest positive integer is represented by that. N is the number of the bits, so 2 to the power of 7 minus 1 is the answer for this question here. Okay, so these are the negative numbers, those are the positive numbers. The answer is this: 2 to the power 7 minus 1. You don't have to calculate what the whole number is. It's 127, and that's for 8-bit. And if it was 16-bit, it would be 2 to the power 16 minus 1 minus 1. That'll be the number of positive integers, minus 2 to the power of n minus 1. That's the number of negative integers. I mean the lowest number, sorry, not the number of negative integers. It's the lowest negative number, and that's the highest positive number integer that can be represented by so many bits. N is the number of bits. Right, now here's a theory question. How does the agile method compare to the iterative method of developing software? So theory question, you can look that up. Agile, for the agile method, you can have evaluation ongoing right throughout the process with the client involved, whereas an iterative, your evaluation only takes place at the end. So they're talking about evaluation. Remember, evaluation traditionally happens at the end of a development of a process. There's different stages of developing software. Over here we have the evaluation or testing and then evaluation. So evaluation will happen throughout the process of developing our software. In the agile method, with the iterative method, the evaluation only happens at the end, after testing. So you have analysis, design, implementation, testing, and an evaluation. So those are the steps: analyzing, designing, implementing, testing. Evaluation is the last step, traditionally, for an iterative methodology. An agile evaluation happens right through all the processes. Right, now we're going to do our conversion of a binary number into a floating point representation. So this is a tricky one. We haven't seen this one before, because basically what we're going to do is we're going to get our decimal point and move it either to the left or the right for the exponent, remember? But we can't move the decimal point anywhere, so guess what? It is naught, and it's a positive naught. What is naught? Naught represented in 8 bits. Naught represented by bits is naught, 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 8 noughts. End of. So there you have it. That is the exponent. Now for the mantissa, you're going to see, we're going to do, you just basically take that 111 as it stands, and then we're going to add enough zeros to make 15 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That will be the mantissa. 15. But what is the sign bit? Sign bit is going to be a negative number. It goes in the front. That is your sign bit. Okay, that one over there. Just add it to the left hand side, and that would be that. Or you can say that the sign bit, it would be better to actually just say that the sign bit is 1, and then the exponent 1, 2, 3, 4, 5, 6, 7, 8. So there you have that. Oh, they want you to put it in here, so we just type in a 1 there, and then you type in your numbers there and your exponent there. Right, so what is the effect of increasing the number of bits when you actually increase the number of bits for the exponent? So when you increase the number of bits to represent the exponent, you're actually increasing the range. When you increase the number of bits for the mantissa, you're increasing the accuracy. So for the exponent, you are you increase the range, and for the mantissa, you increase the accuracy. The number of bits will be the number of noughts and ones, remember? Right, now they say that we have an array called surnames. Fine. That's an array. We're going to assume that it's an array and it exists. Then we have to design an algorithm to find the number of characters in the longest surname. We're going to go through the array, and each box of the array contains surnames. for an example, you'll have Jones in one box. You'll have I'm thinking of surnames here. I can only think of. So now we know that Van der Merwe has a longer surname than Jones, isn't it? So we're going to go through each box of the array. So we need a for loop. Are we going to go through every single box? Yes, because we've got to find the longest surname. And to start off with, we can say that, you know, make a variable called longest equals surnames. We make that equal to the first box, number 0. Okay, so now we're going to go through the array. For okay, in range, why are we going to use a for loop? Because we know we're going to go through every single box. Length of the surnames array, it'll go from 0, don't worry. They say an algorithm, but I'm just using code, Python code, because I find it easier. We're going to check if the length of a surname box number k, if that is greater than the longest, oops, longest can't be that, it has to be the length, not so, length of the first box. I mean, we can make longest 0 if you want, don't have to make it equal to the first box. Anyway, so if the length of the surname is greater than longest and we have a new longest equals the length of surname box number k. We know that length returns an integer, so it'll be a number. I mean, I can put it into 2 words, you know, 2 lines, but I've reduced the code. I mean, I could have said, okay, I could have said, yeah, num equals length of the surnames box number 0, and then num, and the longest equals num. Could have done that. And then I can go and calculate, find the length of the surname. But yeah, I'm actually just saying length of surname. We know it's going to be an integer. So yeah, we'll just do it a quicker way with reducing the number of lines that we have to write. And this is 4 marks. Okay, so basically these are array boxes. I'm just going to delete them because it looks confusing. And that is the code. So we're looping right through all the boxes of the array. And I'm not worrying about the fact that we've already got the first one. You could also say longest equals 0 if you want to do that. You can select, have our initialize our longest as being 0. And then for k in the range from the start to the end of our array. Okay, this is pseudo. This is basically pseudo. It's probably not 100% exact Python, but you don't have to write. Using a design technique, we're designing an algorithm. If we had to put this in algorithm format, we would say over here for this one, set longest to naught, and then for this one, we're going to loop through the array through all indices of the array. And over here we can say if the length of current index is greater than longest, and then we set longest to current array index, array content, whatever content. That's good enough too. So that's one way of writing the algorithm. I find it easier to do it in more obviously Python code, but you won't be marked wrong for that. This is the pseudocode format of doing it. Okay. Right, here we have some theory all about cache memory. So computer performance is improved by having cache memory on the computer chip, the same chip as the processor is, in other words right next to the processor. Why does this improve performance? Well, that's because cache has faster access time than the main memory. Remember, main memory is the memory module further away from the processor. Cache memory has fast access because it's right next to the processor, and it stores frequently used instructions. In other words, instructions that might be used next by the processor. And this cache actually reduces the time that's required to fetch data from main memory, because the frequently used instructions are stored on the cache memory, which is right next to the processor, which has faster access time. Right, now the prime numbers is only divisible by 1 and itself, and we have prime numbers that we can calculate if a number is prime or not. And what this function here is doing, this one function, check prime n function, is actually doing just that. It's checking to see if a number is a prime number or not. We go and look here at the global section here, where we declare input num as an integer from the keyboard. So a user is going to type in input num. It's going to type in input num, and then that is going to be sent off to check prime. Now check prime is the function, and we have to write code over here to call that function check prime. We'll do that just now. We're just looking at our function and our global the main program section. This is the main program section here. Here is your main program section right down here, okay? And then this is your function. Let's have a look at the function. So the function returns a Boolean data type, and that Boolean will be valid prime. Valid prime is going to be returned, and it will become is prime. Is prime is going to hold the value when it returns it. So when we want to call this function, set is prime by calling the function check prime. So let's go and call the function. We're going to say is prime equals check prime, and what's going there is going to be input num. So can you see that? That is our call to use check prime. As you can see, check prime over there. I'd like to highlight that, but I can't. So check prime is the one that we are, the function that we are calling. And when we call a function, we always put it on the right hand side of an equal sign or in a print statement. But more typically it's on the right hand side of an equal sign. So check prime, there it is. That's going to return a value, a Boolean value. Of course this has to be in brackets here, so we need to close our bracket here. Input num is going into that function as it's a variable over here. It's a global variable, and when it gets in here it's going to be called n. Do you see that? It's going to be called n when it gets inside the check prime function. Input num is called n when it gets into the check prime function. Is prime is a Boolean variable that's going to hold the value of this function. In other words, this valid prime here that gets returned. So valid prime, so is prime, we check to see if it's true, then we'll say that it is a prime number. Otherwise we'll say it is not a prime number, though that is fine. But over here we're declaring valid prime initially to be true. So let's look at valid prime now inside our function. We're declaring a Boolean variable, and we're going to make it I want to highlight that. Declaring a Boolean variable. Let's just highlight it quickly with a different color. Valid prime, no, that's, we've used that color, haven't we? Let's make it pink. So valid prime is our Boolean variable, and here it is here again, and here it is here again. So we set valid prime to true. Now n, remember prime number is a prime number is divisible by itself and 1. The value number 1 is not a prime number, so any numbers less than 2, that's just a mathematical fact that 1 is not a prime number. So any numbers less than 2, we're setting valid prime to false, as you can see here. Okay, so we declare it to true here, and then we set it to false if n is less than 2. But if n is greater than or equal to 2, we're going to go from 2 to n minus 1. So that'll be 2. So basically true, 2 is going to be true, because this if statement won't work if the remainder of n divided by the divisor is equal to 0. If that is, our divisor from 2 to n, divisor is going to be our for loop counter, basically. and it's going to start from 2. If n is 2, then this loop won't happen, and it's going to return valid prime, and valid prime is initially true for n being 2, so that'll be fine. If our number n is 3, then this for loop will happen once from 2 to 3, no, 2 to 2. 3 minus n is 1, n is 3, 3 minus 1 is 2, so from 2 to 2, we're going to check if the remainder of n divided by divisor is equal to 0. Let's write the code for that statement there, because they actually want us to do that in the question. So for this particular code here, we're going to write if. And we're going to use mod, which will give us a divisor. If n, mod would give us the remainder. If n mod divisor, now remember divisor is that for loop counter, if that's equal to 0, then we're going to set our valid prime to false, because it means that it's a factor. Our divisor is going to go from 2 to 2, so 3 mod 2 is not equal to 0, therefore this is not going to happen. So as you can see, all of this code here, let me see if I can, all of this code here, this lettering, this wording over here, we have to write the code for it. The remainder of n divided by divisor is equal to 0. We are replacing it with if n mod divisor equals to 0 with actual code, because this is like pseudocode, and in the question they want us to replace that with this. So n is our number that's coming in, mod divisor, which is going to go from 2 to n minus 1. So it'll start at 2 to 2. So if 3 mod 2, if that is equal to 0, no, it's not, because if you take 3 and divide it by 2, you'll get a remainder of 1. So it's not equal to 0. Therefore, this if statement will end, the for loop will end, because we've gone from 2 to 2, and we return valid prime, which is initially declared as true, because n is 3, not 1. Now if n is 5, so we're going to go from 2 to 4, and we are going to divide 5 by 2, then 5 by 3, then 5 divided by 4, and 5 divided by 4, what's the remainder? Still 1. Therefore it is actually a prime number, because it doesn't have any factors, only itself and 1. And as you see, all these numbers have only got factors itself and 1. There's no other factors in those numbers. Like 4 has itself and 1 has 3 factors. So that is what that code is doing. So we're writing code for line 7, which is that if n mod divisor equals 0, line 7 is this, and then over here we were writing the code for this slot, line 43, calling the actual check prime number check prime function. So how do we call it? It's a check prime is a function, remember, and we've got to write on the right hand side of our equal sign is prime, setting is prime. We're saying is prime equals check prime. What are we taking to check prime? Input number. So think of a function like multiplying, or getting a square of a number. So check prime is similar to that. We say a number equals square, and then what are we finding? The square or the square root of a number. So square root will be like a function that we would write here, or square would be a function we'd write here, and in brackets we would have the number that we want to square or find the square root of, and we've got to make that equal to another variable. So is prime is a variable, check prime is a function, input num is a variable which has been input from the keyboard by the user, and it goes off to input num goes off to this check prime, and it's called n over there. Check prime returns true or false. We set a variable to true initially, and then we try and prove that false in this code. Right, moving on. So we have the next question number 7. We're talking about a program or an app which allows users to search for stored recipes. So the app stores the following details about each recipe: the title, the main ingredient, cooking time, cost per portion, average rating. Now, yes, this is they say that they're using a record structure. So it uses a record data structure just to revise our record. How do we declare a record in Python? Because remember, we've done that a lot. So we're having a record or class called recipe, and then we are going to have a title. I know they wrote the record declaration differently there. Main ingredient, this is how we would do it in main ingredient. That would be a string. Cooking time, that would be a float. Cost, portion cost, that would be a float. And then average rating, that would be a float as well. So if we had to declare it in Python, that's how we would do it. Actually, an average rating out of 5, so therefore we need to have it as an integer. I'm sure you recognize this better than this declaration here, but this is just another pseudocode version of defining a record. We're now going to answer the first question there, which says, now that we know what the record looks like, we're now going to look at the next part, which we know what the record is. We have to declare a variable that can store 750 recipes. Now remember, a variable is actually, in this case, it's going to be an array of records. So we will, what are we going to call our array? Well, we can use anything that we want. We know that the recipe is, call it all recipes, and our recipe is actually the record recipe, and then we put in our initialization of the various items, and we have a main ingredient, cooking time, and a title. So we have 2 strings to start off with and 3 numbers, and they want 750 recipes, 750. So you have to memorize how to declare a record and how to declare an array of records. So make sure you memorize that structure. I'm going to try and put this into the actual paper. There we could. I could copy and paste it in, thank goodness. So, our record is recipe, and if you memorize how to actually declare an array, a record, sorry. So what I'm going to do is just copy and paste this. Allow me to, just for interest's sake, so you can actually see what a record looks like. Okay, I'm going to probably have to delete that because that's in the way, isn't it? Okay, we'll just put it over here. Which is not part of the question. That is the question's answer. This is just an aside so that you can see what a record looks like. Right, next question. Users want to search for recipes by entering the main ingredient and the maximum cooking time. So they're going to have two inputs by the user, main and cooking time. We want to display the titles and cooking times of any recipes that have those main ingredients and cooking time. What do we have in our record again? We have main ingredient and cooking time. You can just call it main, I suppose. I could just call it main. So we want to go through our array of records to see which recipe has the same main and the same cooking time. And then we are going to display the titles of the maximum cooking time. So it has to be maximum cooking time in minutes. So we have to look for the main ingredient in all the recipes and see if the cooking time is less than or equal to this maximum cooking time that the user types in. And if there is no matching criteria, then we're going to say no match is found. So they say use a programming language of our choice. Yes, we're going to use Python because we're used to that. Write the code to display this information. Your answer must include use of the record data structure. Yes, of course it will. Yeah. So let's go get our input, shall we? So we'll say isMain equals input, enter main ingredient, and then we have max time equals input, enter max cooking time. So there we get our two inputs. Now we are going to, oops, sorry, what happened there? Alright, so now we are going to go and start our loop. Now we know we are going to go through each item of our array to look at the cooking times and the main ingredients. Main and cooking time, we're going to look at both of those. We do have to use the wording that they gave us in the recipe. Title, ingredient, minutes. Oops. Title, we'll have to use that wording, not main. Ingredient and minutes. We have to use that wording in our record structure. Minutes, because that's what they gave us over here, you see? And then our cost and AVG rating. Right, so when we refer in our code, we've got to use those words. use these words: title, ingredient, minutes, cost, average rating. Right. I think I'm going to put this further down so that I can see it in on this page. So there's my record. Right. So in here we will then go and put in, we're going to loop. Are we going to go through every single box of the array? So yes, 4. Naught, comma, length, arrow players. 4 x, and we're going to use the same format that we used before. 4x in range, naught, comma, length of our array. What's the array called? Recipes. No. What did we call our array? We called it all recipes. Remember? All recipes. So what are we going to do? Yeah, I did it again. Can't use tab, obviously. Oops. Can't use space either. Yeah. Goes to the. Oh no, it doesn't go to the next one. That's fine. Remember, we have to indent our code. So for x in range, naught, all recipe. What are we going to do? We're going to check if all recipes square brackets x dot main, if that equals s main, that one coming in there. So where we get main from? It's from, oh, ingredient. Sorry, it's not main, it's ingredient. Ingredient. Remember, this is our record over here. Wish I was able. Oh, I can move it. Thank goodness. Sure. If that equals main, and we want to know if the cooking time or minutes is less than or equal to the maximum time that the user typed in, and all recipes square brackets x and minutes, if that is less than or equal to max time, then what are we going to do? Where does max time come from? Over there. What is s main? S main comes from there. So we've got that set up. If the conditions are met, what do we want to actually do? We want to display the title and the actual cooking time of that recipe. So we want to display print all recipes square brackets x dot title, which is that one there, and we're going to join that to a space. Actually we're supposed to say requiring. If you have a look there, title requiring plus. Now we have to convert our all recipes, our actual cooking time from the array of records, which is minutes. We are putting it in a display, therefore we have to convert it to a string. And join the word minutes to the end of that string in our print. Now that's looking good, but there's just one problem. What if we don't find a match at all? We do need to actually have some kind of a flag which will say, okay, we found, or we didn't find one. So let us try this. Let's make a Boolean flag, be found equal to false. If we find a match, we will set be found to true, one would think, yes. Be found equals true. I always put a B in front of the found because I want to see that it is a Boolean variable. So that would be good enough inside our for loop, inside the if statement actually. So we need to remember that if we find a match of both of those, the main ingredient, the ingredient is the same as S main, and the minutes are in the maximum time allowed, we will set our be found to true. We will also display the title and the minutes. Now that all's going to happen in the for loop. We now need to get out of that for loop and our if statement. Take note of where the for loop is, and it's indented. The if statement's inside the for loop, and then in the if statement you indent our print and our found, because we only do those two things if there's a match. The for loop is going to go from every single box of the array, and then we're going to have we have to ask ourselves if be found is still false. If it's still false, then we want to display over here inside this code print or display no matches found. So be found, even if there's only one match, be found will be set to true. If there's no matches, then be found will stay false. So that is a cool trick, isn't it? We do need to make sure that we have our end if and our end for. That's why if you look at the answers, they use pseudocode, and this is end if, and over here we would end the for loop, and over here we would say end if as well. Even though it's not Python code, it's just putting the contents of our for loop and our if statements in order. Right, if you didn't quite get that the first time, go through it again. Moving on to the next question. A program should generate a list of unique random numbers between a lower and upper limit as chosen by the user. Two boundaries of the problem. Well, there should not be any random integers between a lower and upper limit. So if our lower limit is 0, well, if it says between, so no numbers less than or equal to 0 can be used. Only numbers greater than 0. And the the minimum value must be lower than the value must, oh gosh, I pressed enter and then it did that. Minimum value must be lower than the maximum value, and vice versa, because we want to go from the low to the highest. So So all inputs must be integers. Yeah. Right, moving on. So here we have a function called valid num. It's used to check if a number is already present in an array or not. What's going to happen is generate unique. There's got to be unique random integers going to be generated between a lower and upper limit. And valid num is going to check that the number has not already been generated. So we want to see if a number actually exists in an array. So array of integer values, that is a variable, an array called values. So our array called values, let's go and highlight this one. I want to highlight it. Right, so values. Where else is values? There's another reference to values, and there's another reference to values. Right, that's our array coming in. And then we're going to have random number. Random num. That's coming into our function valid num. So random num is there. And then we have a Boolean variable called valid. Our function is going to return Boolean. Can you see that? So we have a Boolean variable called valid. It's always nice to highlight these things so you can see what's happening with your code. So I'm going to look at our Boolean variable called valid and see where it occurs everywhere. I'm just learning to understand my function itself, and that sort of helps me to do this. Might help you. So we declare valid initially false, and we're going to go using index from 0 to length of values minus 1. So we're using a for loop as our index as our, and the index is a, oops, let me undo that, sorry about that. I don't want that color, I want yeah, we've done yellow already, haven't we? Let's use this one. So index is here. Is our for loop counter. So for the loop counter is going to go from 0 to the length of values. Values is our array that's coming in. Length of values minus 1, that's our normal for loop going through an array from 0 to the last box or index. So if that array, box number or index, if that's equal to our random number, then valid is false, meaning that the number exists in the array called values. So we're checking random number here to see if it exists in our array, and if it does, we'll set valid to false. We've declared valid initially false, which doesn't sound quite right, does it? So we're going to go and see what's wrong there. Well, we're going to fix that just now. Before we do that, let's have a look at our main program. This is the main program. So I'm just going to go and put your hashtag main. So there's our main program. So what do we do in the main program? We declare a random list as an array of integers. So we'll have this random list, and we are putting zeros in all of them. So we have another index. This is our global variables. So we must program with global variables. And the global variable is our random list array, our index over here, there's random list, and random val. So we have that, all the global variables, random val, and random val is a random number between a minimum and maximum value. And then while valid, now it's calling the valid num function. So here's valid num over there. I like to highlight this, I mean underline it, but basically what I can, the only thing I can do is basically the only thing I can do is underline it. So what I'm going to do is I'm going to make it a grey color. So valid num is sitting over there. Valid num, yeah, we are calling it. Valid num is a function, yeah, we are calling valid num with two parameters over here. Random val and random list. I will actually just use a draw random val and random list. Two things are going into valid num. Random val is the actual parameter and random num is a corresponding formal parameter. Random list is our actual parameter, it's an array. Remember, there it is there. And random val is here. It's a random number. So random list is our array called values. So random list is our actual parameter and the corresponding formal parameter is called values. Okay, so these are your parameters of your function. They're the formal parameters. There's only two of them, and here are they are being called and being replaced. Well, random val is now going to be called random num, and random list is going to be called values in our valid num function. Here's our call to valid num function. So we can call a function, we don't have to put it in an equal sign, we can use it in a while statement. See how they're using this valid num function. Remember I said you call a function on the right hand side of an equal sign? Well, yeah, they're actually calling it in a while loop, and that's fine, you can do that too. So valid num is the function call, there it is. Two things are going to it, random val and random list. They're going to be called random num and values once they get into valid num. And then we're going to return a true or false, and they're asking if it's false, then they're going to say random val, we're going to generate another random number. Random val is going to be regenerated, because there we generate a random number between a minimum and maximum value, put it into random val, send it off to valid num along with our random list. Where's our random list? Here it is. Yeah, I wonder, our random list is supposed to, yeah, we are actually going to add our random val to the random list right down here, if it is a valid num. So this is our main program, which is going to generate a random number, put it into a list, an array called random list, at an index of 0 to the length of random list. But the only problem, oh yeah, size of the array is going to be put in there. We're not so sure how many values will be put in there, but yeah, that will be put in there. Anyway, let's have a look at our questions. An error is found in the valid num function, and we actually found the error, didn't we? When we were going through it over here, They declare valid as being false, and then they set it to false here, which means that actually it'll always be false. Valid's going to always be false. And if it's always false, we're going to constantly regenerate a random number. So the problem is that this declare valid initially false, that is our error. So declare valid initially false, declare valid initially false is incorrect. It should be declare valid initially true. Because otherwise the function valid num will always return the value false. Uh-oh. I would like to get this onto the next line. What will effect have when line 63 to 70 will be executed? Well, the for loop in 63, the for loop in line 64 will never end. It'll always be false. Will constantly generate a random number all the time. Why? You want to ask yourselves. Because, oops, I just want to make sure you can see my screen. No, you can. Because we're going from 0 to the length of random list minus 1. Random list will initially, maybe it's 40. But while valid num is false, we're going to always be generating a random number. So random val will be a number generated, okay, then we send that number to valid num, it'll be false, and we're going to generate a random number. We will never ever be adding anything to our random list. We'll have to constantly generate a random number here, because it will never be true. If valid num is true, then this will happen. That line is never going to happen. Never. Because valid num is always going to be false. Because we set it initially to false there. So, the correct way to put that in we'll have an infinite loop. Yeah, this while loop here in line 66 will never end. So the while loop in line 66 will never end, be infinite. And we know what that happens, that means, eh? Infinite. Infinite loop means your computer will be freezing and you'll have to close the program. Condition 66 will always be 66. So valid is always false. Valid num. Because valid num, oops, I must write it in here. Why is it not typing? Okay. Oh, I don't know why it's not typing all of a sudden. Anyway, because valid num will always return false. Okay, so there's 2 marks for that. So now we say the error is corrected, okay? So declare valid initially true is corrected. Describe how valid num function could be made more efficient. Well, so let's say this has been set to true, okay? It's not false anymore. How can we make this thing more better? Well, first of all, the for loop is going through every single index of the array, okay? That for loop in line 36 is going through every single index. Maybe you want to stop when you find a match. Otherwise, why are we going to go through every line, every index of the array? We want it to stop. So using a while loop would be better. While valid equals true and index less than or equal to the length of values. So we would rather, instead of that line, put in a while loop. While valid equals true and index is less than or equal to the length of values. Let's get this onto the next line. Length of values -1. Then what will happen is, as soon as we find a match, then the loop will stop, or this index means it will go right to the end. So you have to have 2 conditions of the loop. So we're going to write down an answer here. The for loop will go through every index of the array, and that wastes processor time. Therefore, use a while loop with 2 conditions. 1 to check that valid is true, and the other condition is to check that we are not at the last index of the array. In other words, the loop will stop when it reaches the end of the array and no and valid is still true, and valid is still true. So we need to so that is one way of answering that, I would say. I wonder if I can put it on that now. I'll put it on these 2 lines like that. So that means the loop will so this means that the loop will stop when valid is false or when the end of the array has been reached. So I want you to just study those lines, if you can see them. It's a little bit tricky, isn't it, to get this position so that you can actually read the answer. I think that's good enough. So there you have it. That is my answer. Obviously the therefore, and I've actually put that code over here so we can actually go and put that in here too. Okay. Uh-oh. That didn't really work, did it? Okay, so formal and actual parameters are used in the code. Identify a formal parameter for the valid num function and associate things. So that's easy. Remember I showed it to you before. A formal parameter is random num or values. Random num and values are formal parameters. The actual parameters matching them are random val and random list. See? Random val and random list are the actual parameters. So you don't have to both of them, you can just choose one. I'm just writing both so that we can see, you know, that there are two. So next question. So we have an insurance company here that's going to have a black box installed into a cars. That's going to record the date of travel, distance, and the time. And we have a text file. Now you're probably thinking, array of records. Not quite. In fact, in this one, it says we are reading the data into parallel arrays. Parallel 1D arrays. So we have a problem if we think we're going to actually have an array of records, but it's not a problem. So there's our text file with the date of travel, the distance, and the time spent. And instead of an array of records, we're writing it into, oh, where is my nice little sheet that I made? Here it is. We're writing it into this structure. In fact, I will delete these columns so we can see it better. I don't have to make this much larger. So there we have our arrays. The date array, a distance array, and a driving time array. So read the data from text file into parallel 1D arrays. And they're parallel arrays because each index is connected. So index 0 of date refers to the date, and the distance on index 0 is the distance for that date, and the driving time on index 0 is the driving time for that date. So they are related on each index, and that's why they're called parallel arrays. Calculate the average speed for each individual journey by dividing the distance by the journey. Ooh, look what we have here. Top level design. We have to describe what are the ins and the outs. So when it's blanked out like that, you don't have to write anything in. Calculate the average speed for each individual journey by dividing the distance for that journey by the time taken for that journey. So we're dividing the distance by the time. So if we look at that carefully, you'll see that we're actually going to use distance and time, aren't we? So we're going to use our distance array and our driving time array. That's going to go in here because we want to calculate the average speed, don't we? So let's go and do that. Distance is going in here. Distance and driving time. Okay, what's going out? Well, the average speed. Average speed. I'm just going to call it a, oops, why is it not typing? Average speed. That sort of makes sense. So, is it going to be an array? Well, the memo says so for each individual journey. So we're going to go through every item and we're going to create a new array called average speed. So there's going to be a matching average speed array here. So this is our average speed. Come on, I want to. There, so we have average speed, AVG speed. And I'm referring to this as an array, so I'll just use the round brackets. So there you have another array that's going to be calculated. Distance, driving time. How are we going to calculate speed? Distance divided by time. So it'll be equal to that distance divided by that time. And then, oops, I'm not getting a calculation here because these are numbers. My bad. Anyway, these are numbers and I've formatted them to text, which is why I can't do a calculation, but let's just quickly format them to numbers again. Okay. And then we can do our calculation and we'll show the speed just for fun. Let's do it. Right, equals distance divided by time. Oh, still not. Oh, because this is also a text data type. I formatted this as text so that I could do things with it. Let's just format this one also as a number. At least you're learning a bit about Excel as well, why not? So it's equal to that divided by that one. And then we have our average speed. That's what we want to return in this particular number 2. Now, number 3, the average distance for journeys longer than 1 hour. Uh-oh. Any journey that has a driving time of longer than an hour. So we want distance and driving time. So guess we're going to use distance and driving time as well. And driving time. Driving time. So as you can see, when you want to refer to a whole array going in and out, you have to use square brackets over there. And what is going to come out is the average distance. So those are the only two things that will go in there. 4 is a little bit complicated, doesn't have anything going out, and the reason is because it's a procedure. These other two here are functions, and that could also be a function. Reading data from text file into array, and these two are definitely functions. And this one is a procedure because it's basically writing to a text file. Remember, displaying and writing to a text file are procedures. They don't have anything coming out because it actually does it in the procedure itself. It doesn't return a value, whereas these others return values. So writing the average speed to a text file, what do we need to do that? We need average speed and average distance. Do we want the average distance? Oh, it have greater distance than the average distance. So we do need the average distance because that's going to be used in our comparison to see if their distance is greater than average, and we also want the average speed. So our average speed array that came out of number 2's program code has to go in there. Is there anything else that has to go in there? Average speed, average distance. Well, we want the distance array. So average distance is a number, average speed is an array, and we want the distance array as well. So we're dealing with, let's go and do our highlighting. We're dealing with, I'll use a different color. We're dealing with the average speed. We are dealing with distance, and we're also dealing with average distance. So if you look at it like that, then you'll be able to see that actually we're going to use average distance that came out of number 3, and that was given to us. We're going to use average speed, which we figured out was coming out of number 2, and then we also need the distance. So let's go and put in our distance here. Distance, square brackets for the whole array. So you see the difference between working with a variable, a single variable, or an array. Array is also a variable, but it contains a whole lot of indices or boxes. Remember, so it's a much larger variable than just a variable on its own. So that was a tricky one. Go over it again if you don't understand it the first time. Now, the next question is explain how the data flow identified the design stage is going to assist with implementation. So we're talking about implementation. We're not talking about testing or evaluating. We're talking about implementation, which is not the same thing as testing, evaluating, designing, or analyzing. So how does this data flow over here help us with actually implementing? Implementing meaning writing the code of the program. So basically it helps us to see what our parameters are. It helps, we can see what the parameters of the different methods are. Now remember, methods is it's not very good English, but because here at the back I want to say methods in brackets, procedures and functions. And what's another word for methods? Subroutines. Okay, now step 3 calculates, and now we're going to do a design. And this is going to be using a design technique, so we actually have to use, which I hate this, but we actually have to use pseudocode. So yeah, I like to work it out in Python first and then pseudocode. It's up to you. Nothing stopping using a mixture of pseudocode and Python. So I will just do my own thing here for now and then convert it to pseudocode, because I want to explain the process of doing step 3, writing the code for step 3. So the average distance for journeys longer than 1 hour. Let's have a look at step 3. What's going in? Distance, driving time, average distance. So we have to average distance for longer than 1 hour. We're going to go through all the arrays, and we're going to go through distance and driving time array. Now remember, they are looking like that, distance and driving time. We want to see, if you look at this, then it sort of makes more sense, doesn't it? We want to see what is the calculate average distance. We want to see all the journeys that are longer than 1 hour, and we're going to calculate an average distance. Now the thing with calculating average, and I want to highlight the word average, because average, what do we need when we want to calculate the average of anything? We've got to need the sum and the count. So what do we have here? The sum of all driving times that are greater than 1 hour. I don't know if that can be equal to 1 hour or greater than. Longer, greater than 1 hour. So at the moment I only see 1 over here. The time is there's only one distance, but we want the average distance. So we're going to sum up all the distances if the driving time is greater than 1 hour. We're also going to count how many distances there are, because remember, average is always equal to sum divided by count, or our total, you know what I mean? A total, that's how you get the average of anything. The average of 3 numbers like this, equal average. If you get the average of these 3 numbers, we're actually summing up. We get the sum of them and we divide by 3. Now of course I have what's the sum of those 3 numbers? Just work it out. 5, 6, 7, 8, 9, 2, 3, 40. It's 50.49. That's the sum of those 3 numbers. And then the count, how many are there? There's 3 numbers. And then you're basically going to say 50.49 divided by 3, aren't you? And then you'll get your average number. Oh, this is total. Let's call it total. So we're adding up and we're counting. And that's what we have to do in our program code. We have to get we're going to have global variables to add, to count, and we're also going to have global variables to total. So the first thing I'm going to do is declare and set my totaling and counting variables. We always have to initialize them because we're going to add them up in a loop. So I'm going to say total equals 0 and count equals naught. We need a totaling variable and a counting variable. We're setting them to naught. We have to initialize them, otherwise we're not going to be able to do anything. And then we're going to go through our arrays. Now remember, we have these parallel arrays. We're going to go through distance and driving times. And when you go through any array, we have to decide whether we want to stop the loop, because we can use a loop to go through the array one box at a time. We have to decide whether we're going to have a for loop or a while loop. A for loop is going to be fixed. It's going to go through every single box of the array. A while loop, we can stop going through the array at any time. But in this case, we want to go through every single box because we want to see all the driving times that are greater than 1 hour. Okay, we're not worrying about the speed right now. So we're going to use a for loop. For x in range 0 to length of our, doesn't matter which array shall we worry about. Well, we want to go through the driving time array to see which driving times are greater than 1. Sorry, not so. So let's start with the driving time. Driving time -1. So that's basically just to let us know we're going through. Then we must indent. It's our loop, isn't it? So average. So we want to count how many journeys there are, and we also want to get the distance. But first we want to see if their journeys are longer than 1 hour. If, is that array called driving time? I think it is. Yes, it is called driving time with a capital T, isn't it? So if driving time, oops, we don't want to do that. Driving time box number X is greater than 1, then what are we going to do? We're going to do our total equal, we're going to accumulate our total plus what? The total distance. We're going to total up our distances and then count how many there are. So what is our distance array called? It's called distance. Square brackets x. So it'll look through the first array and it'll see, oh, the driving time is greater than 1. So that's going to be total. Our new total will be 40.25, isn't it? Okay, forget about that for now. We've finished with that. We know how to calculate average. So the total is now going to be 40.25 for the first index of the array. But we also have to add 1 to our counter, because remember, when we calculate average we have to have a counter as well as total. So we add 1 to a counter. That's in our for loop. And guess what? We now go and calculate our average will be equal to total divided by count. There we go. And we're going to return that. And that's 4 marks. So this is basically an algorithm, but I haven't really written an algorithm. So over here I'm going to write the algorithm. Set total and count to 0. Loop through driving time array if driving time is greater than 1, 1, then add 1 to count and add distance to total variable. And we've got to say end if. And then we've got to say end for loop or fixed loop. So this end if has to come over here. We have to notify that we're ending our if statement, and then over here we end for loop and we calculate average and there we go. There's the pseudocode, and that is our program code that we used to, and that's 4 marks. It wasn't so difficult, was it? Right, moving on to the next one. The company has been the target of denial of service attacks. What does denial of service mean? Right, so denial of service, it actually attacks our resources. What are resources? So we have the resources. We have storage is a resource. Our processor is a resource. Our RAM is a resource. So basically, all of these become exhausted, become fully used and exhausted. So fully used. So the RAM runs out of space. RAM runs out of space to store, and the storage also runs out of space. The processor is basically overworked and fully utilized. So one of those things will be fine in an answer on this one. As they say, 1 mark. Stage 1, cost to the company. So what's the cost to the company? So basically you lose money, loss of money, revenue. You have to repair damage due to attack. You have to say due to attack, and also have to upgrade system to prepare for future attacks. So that's going to be money. Right, so we are now moving on to the question 10, and that will be the last in the software development section. So we use a smartwatch to track the distance that he walks every day, and he's targeted to walk 5 kilometers or more every day. So it's his target, 5 kilometers or more, and he's got data of 5.2, 4.2, 4.0, 4.8, 5.8, 5.2, 6.4, and they said the expected output should be 3. No, the expected output should be, so there's a misprint here obviously. The expected output should be 4, because there's 1, and there's 1 over 5, and there's 1 over 5. So I count 4. so don't worry about that. That's not 3, it's 4. Just a misprint. Doesn't really affect the running of the questions. Right, so now we have code that we're going to go and actually we're going to trace through. Have a look at that. That should be fun games. Now in order to help, I've actually got a little spreadsheet over here. Where is it? Right, there it is. I suppose I don't need it now that I have my super duper thing working, but I think it's going to help so that I can move this over to the code. We are going to complete a trace table and then find out what's wrong with our program. They say the trace table, they're telling us it's the first 2 iterations of the loop, and it sure is, because we are doing 15, 12, 13, 18, 20. 15, 12, 13, 18, 20. These are the lines we have to fill in. These ones right here. So let's get on it. We're going to go and see how this works. And there's nice line numbers to help us. Tracer indicate the line number where a variable changes and the new value of that variable. So they left spaces there, okay, but I'm going to fill them in. We don't have to fill them in, but we're going to. They say that we should indicate the line number where a variable changes. A new value for that variable. Okay, so trace tables are actually quite easy. I know you find them scary, but they're not. You just need to look at the numbers, and they've got nice line numbers here as well. So should we dive into the trace table, or should we have a look at the code a little bit more? I think we'll look at the code a bit more first. So here we have a function called consecutive days. That's going to return an integer data type. Fine. It receives an array of real values. Let's have a look at the call. Here it is. We're using consecutive days, and I'm going to highlight this. Consecutive days is being called by the statement right at the bottom here in the global section, the main program. Here it is. It's going to have an array variable called distances. Can you see distances is an array because it's got all these numbers in there. Set distances to that, and that's also how you can declare an array that's already filled. And basically we're setting days met is going to be an integer, the number of days, and it's going to take that array called distances. It's going to be called values. So let's go and highlight our values is the actual parameter. Down here we have the distances, which it's going to be replaced by. So distances is an array, and it's going to be called values when it comes in here. So where's values? Here's values. Do we refer to anywhere else? No. Okay, so our whole array is going to be worked on. What have you got here now? Counter is set to 0. And I want to trace that counter. So we have a counter here set to 0. So here's our counter set to 0 as well. And here's another counter having 1 added to it. And here's another reference to counter. So it looks a little bit suspicious, don't you think? How many counters are set to 0? Immediately I can see that counter set to 0 is wrong, but we're not going to try and fix the code now. We're going to trace through the code. And afterwards then we will fix the code. So I will just leave this counter being highlighted everywhere, and we'll look at everything else. So we declare counter to naught, longest streak is set to -1. Okay. For index from naught to length of values. So we're going to go through the array that's coming in here from the first to the last box. Here we're setting counter to naught. If one of the items in the array is greater than 5 or equal to 5, then we're counting this counter is going to be incremented. Okay, if it's not greater than 5, then we're going to say if the counter is greater than the longest streak is -1, then we're going to set longest streak to counter. And if. And here we're setting counter to naught again. Not right. Okay. This. Alright, so end of the for loop. After the for loop, if counter is greater than longest streak, then we set longest streak to counter. Fine. Let's just trace through it. It's a little bit of a mess. I'm sure you can see that. So, line number 10, counter set to naught, okay? Fine. Line number 11, index is not accessible. Longest streak isn't accessible. Oh, for crying in a bucket. Let's get these things to text immediately before I go any further. We want them to be text, not anything else. Come on. Home, font, that's better. Number text. Oh, it is text. Okay, fine. Right, so this is going to be a nothing, and this is nothing. What is this? The longest streak. We've only got these counter, index, and longest streak to worry about. The line numbers are just the line numbers that we have to deal with for each variable that is changing. So what's happening to counting number 10? It's been set to naught. There's number 10. Index is nothing, longest streak is nothing. In line 11, counter is still naught, index is nothing, and longest streak is set to -1. Right, line number 12. What's happening line number 12? Counter is still naught. We don't have to fill this in. Index is going to be naught. Longest streak is -1. In line 13, by the way, you don't have to fill in the ones where it's not changing. In line 13, counter set to naught, index is still naught, and longest streak is still -1. Then in line 15, oops, come back here, you. Right. In line 15, counter is set to counter +1, so now it's 1. These still remain the same, and we're going back to line 12. If value is greater than 5.0, there's else. So the value is greater than 5.0. So we go back to, because if that if statement works, then all the else's are not going to go into, you know what I mean? So if the if statement works and the else part is not going to happen, then we go back to the for loop to line 12, and counter is now 1. No, counter stays 1, but index is now going to be 1. So I can put this here if I want. And longest streak is still -1. Then in line 13, set counter to 0. Oops, counter is now set to 0 all of a sudden. And these two stay the same. Okay, what's line 14 doing? So let's have a look at our index is 1. What is values index? It's now 4.2. Before it was 5.2, which is why we were able to do the rest. Index 1, it is not greater than or equal to 5, therefore we do the else part. Is longest streak greater than, is counter greater than longest streak? Yes, it is. So 18, we're setting longest streak to counter. So now longest streak is now whatever counter is. Oh wait, it's 0, isn't it? Because counter is 0. Index is still 1. Because what happened in 13? In line 13 we set counter to 0. We checked in line 14. Well, we don't even go there because index 1, because is now index is now going to be 1. Why? Because it was 0 before, now it's 1. Okay, at line 12 index is 1. And in line 12, yeah, 12, 13. Okay, in this line 14, basically we do not have a match there, so we go to the else part, because values, the array box number 1 is 4.2, which is not greater than or equal to 5. There we have to go to the else part in line 17. Is counter greater than longest streak? In line 17, yeah, counter is 1, longest streak is -1, so therefore, no, counter is 0, longest streak is -1. Therefore, we're going to set longest streak to counter in line 18, which we do. Then we're going to set counter to 0 over here. 0. And that is your answer. And the ones that are changing is this one, and I'm going to highlight it, this one and this one and this one and this one and this one. Now those marked in yellow are the ones that you basically, they're changing at those line numbers. So that was quite tricky, I'm sure you'd agree, because we have to worry about what's happening at each each run, each line. Sorry, I just want to get this out of here because it's irritating me. Okay. Right, so it's a careful trace through. What I would do if you is I would practice going through the lines. And let's go to the next question. Practice going through trace table. State the line number of the code that should be removed to correct the algorithm. Well, if we look at our trace table, we're setting counter to 0 over here in line 13. That shouldn't be. So therefore, line 13 needs to be removed. What is line 13? It's right here. That should be, oops, sorry. That should be removed. Shall we change the color to purple? That must be removed. Anyway, so there you have that. Right, C and D, that was 3 marks. C, state, yeah, we did that one, 1 mark. Name and describe a debugging technique that can be used during the execution of code. Now, there's 2 types of debugging techniques, a breakpoint and a watch point. And this is what you have to memorize, and you can look at the memo as well. So a breakpoint stops your execution at a specific line. Okay, so we can see how the variables are compared to expected values. We inspect our variables, we stop execution at a specific line, whereas a watch point stops execution when a variable changes. So yeah, I can write it out, I guess. Debugging stops execution at a specific line, and watch points stop execution when a variable changes value. And both of them we want to describe how it works. For both, you've got to describe one correct description and one thing. So you can either describe debugging or watch points. So why do we use debugging? That allows variable values to be checked if they are what is expected. And the same with this one. So if they are the values that we expect them. So you just have to memorize so we can inspect the variables, and for both of them it's for inspecting what the variables are, if they are compared to what we expect them to be, but the operation is different, because breakpoints will stop at a certain line, a specified line, and watch points will stop code at when a variable actually changes value. So the watch point will stop execution when a variable changes value. But in this case, they want only one debugging technique to be described, not both of them. So you get 2 marks for debugging, or you get 2 marks for watch point. You're not going to get 2 marks if you say debugging and watch points. You understand? Name and describe it. Debugging technique. 1 debugging technique. Describe it. Name it and describe it. 1 debugging technique. Either breakpoints. Sorry, what did I say? Debugging. It's supposed to be breakpoint here. Breakpoints. And then watch point. But you don't talk about both. If you only want 1 debugging technique, make sure you only choose 1 and then describe it. Scope of the variable counter, it's local. That means that it's only used inside the method. Is it a function? It's a function. Function. What's the function called? Counter. Consecutive days. So basically it gets deleted from RAM when the function ends, because otherwise it'll be taking up too much memory. That's why we want local variables. Right, here we have some more theory, 2 marks. Describe how modular programming increases efficiency and maintainability. Modular programming does that. Why does it make it efficient and why is it called maintainable? So you need to memorize these theory questions. So basically efficiency, because we can call a function methods or subroutines, methods, functions and procedures, these are all names, are able to be used more than once, and local variables are in memory only while the subroutine is being executed. That's why it's efficient. Maintainability, easy to fix an error in a method. Easy to find and fix an error. Easy to find and fix an error in a method. What's another word for method? Subroutine. More function and procedure. Oops. Getting ahead of myself, yeah, aren't I? Right, next one. You need a couple, don't we? Easy to test. Oh. It's easy to test. Easy to make changes. So there's a whole bunch of them. 1 mark each. 1 mark for efficiency, 1 for maintainability, and that's quite clear. Right, so we'll finish with this one, and we'll see you for the databases next.